Hello YouTube, De-bodgery here. This is the last iteration, I think, that I will make of my spot weld cutter that I have nicknamed Mr. Snippy. Anyway, you are looking at the bottom side of a cell. It's upside down, but you're looking at it in a mirror. So this allows me to see underneath the servo and be able to see the bottom of the cell. And as you can see, the camera will focus, it is on a wedge. And the shape of the wedge and the position of the wedge is, designed so that with the machine basically sideways to me, I can see the bottom of the cell like you can see there, and I can also see the actual cell from the other side. So, all I have to do is butt the cell up, turn the knob, and chop. So I can't hold the camera and do the cutting at the same time, but and also of course got to get the camera in the right location. But anyway, all I can do is sort of demonstrate. Come on, camera, focus back on the bottom of the cell. There we go. So anyway, here's an 18650 in there. The potentiometer now has a second trimmer pot in series with it that creates a bottom deadband. So that's the minimum position on the main pot, which is pretty darn close to the bottommost position that I can get on a cell without actually like shearing into the shrink wrap on the cell. And 18650s is probably the smallest cell I'm going to deal with, so that's pretty much the lowest position that I am likely to ever need the blade to be in. So the little trimmer pot might get adjusted again. I don't know, but hey, it's in there. I can always adjust it as needed. But, up. So that's pretty much like up, and that works for the bottom of a cell, or flip it over. And with a cell like this LGMH1, it's got a paper washer on there. All I have to do is butt up against that. I don't have to butt up against the button like I am right now on this one. Like up there, that's just as good because the paper adds just enough thickness for the blade to clear the protrusion of the button so that it comes right down and doesn't catch. If the paper washer's not on there and I just butt up against the top shoulder of the cell, the blade does come in just a skosh and it will catch the edge of the cell top. So that's just something to be aware of. But with the paper washers on there, that is completely not a problem. So like I'm pushing the cell, you can't see this off camera, into the right there, into the cutter, and then I'm going to turn it, and it just completely clears. But anyway, yeah, I can't hold the cell in place, hold the camera, and turn the knob all at the same time. It's too much to do. All I can do is kind of like hold it just sort of loose, like with my thumb. But anyway, so like this cell, the top and the bottom of the cell. Come on, camera, get back in there again. There we go. Focus on that. The top and the bottom of the cell. In fact, here, I'll just do it this way. This is one that I just sheared. Come on, camera, focus. Focus. Yeah, there we go. So you can see that's completely smooth. You can just see the scrape mark on there from the blade, but the spot welds are gone. And flip it over. Yeah, and there we go. And you can see that those welds are also very shiny and flat. You can't feel them. They're very smooth. All you can see is the discoloration. Anyway, macro lens is great for stuff like this. It just doesn't want to focus on longer range stuff. It doesn't like complex focusing scenarios. So anyway, yeah. Here's another one, same situation. The bottom of the cell is very flat, very smooth. Yeah, the welds are just completely flush. And the top of the cell, same thing. It's completely flush. It just shears them right off and it leaves a nice flat surface. If you don't have a spot weld shear like this and you're still doing the slow and tedious method with flush cutters like I've done for so many years, well, all I can say is you need to build yourself one of these things because, wow, this is so much better. Just tons better. To do, come on, camera, focus on that. To do that one shear right there takes, I don't know, a second. Whereas to get it as good as this, Come on, camera, focus. There we go. To get as good as that, takes probably 20 seconds, 30 seconds or so. So the spot weld shear is much quicker, and it produces a much better result. Because this is what I get with flush cutters, and that's as good as I can get them most of the time. And the bottom of that cell is the same way. You can still see the spot welds on there. So, that's pretty good, but it's not as good as Mr. Snippy, not by a long shot, and it's way slower. Mr. Snippy does and it's done. So anyway, I showed the mirror. So this little wedge in here, just positioned just right, so you can see the cradle from the back side. You can kind of see it back in there, but that's just a very, very weak ceramic magnet to collect the metal bits. The servo, if the camera will focus, there you go, is mounted sideways on the aluminum now. Originally I had it vertical, and now that's sideways. Kind of clears the top of this thing, but I did it for other reasons, to rotate it. It made other things happen a little bit better. And around this side, so there we go, you can see my little magnet ring back in there, just to collect the little metal bits. So here's my cradle. I now have a couple of pieces of fiberglass sheet stuck down with double-sided tape. That way, if I did have a cell in here with all buggered up heat shrink on it, I can't create a short between the cell button and the cell can anymore. And so yeah, that just totally takes care of that problem. And being that it's just fiberglass stuff, it's probably never going to wear out. Anyway, here's my potentiometer. So let's see if I can't get both of these on camera at the same time. So that's all the way down. Pot's all the way in its bottommost position, and the bottom of the cell, there we go. And that puts the blade right at the edge of the heat shrink. So that works out super well, and I don't need to go down further than that, and it's highly unlikely that I will ever cut spot welds off of a smaller diameter cell than an 18650. So anyway, set the trimmer pot to that bottommost position, and by the way, this is a 10-to-1 ratio, so this is a 10K pot, and that's a 100K trimmer pot. So this has basically got 10% of the rotation, depending on where that one is set, of course, and that would have the other 90%. And most of the rotation, in fact, of this servo is actually in this direction, and I only need a small amount of movement up here. So if the camera would focus, so that's all the way down. Come on, camera, focus. There we go. And that's all the way up. And that puts the blade just flush with the bottom of the bottom bearing block, which is all the more I need for, like, say, a 2650 cell, or whatever that is, 26700, yeah, 26650 cell. Yeah, those ones, like A123 cells. That's all the more I need is that height right there, so that works out perfect. Yeah, and that's the maximum position on the pot to get the blade all the way up in this position. And all the way down, that's the lowest position I'll ever need the blade to ever be in. And the trimmer is making that dead band so that the main pot doesn't go any lower. Now that this is all set up and working, I can take this pot and I can replace it with 2 resistors and a push button. So that's 10K in that position, so all the way down. And this is essentially, 0 ohms in that position. So with a push button and 2 resistors, I can just hit a button and the whole thing goes zzz, zzz. When I release the button, it'll just raise right back up again. And when I push it, it'll go right back down to that spot. And so, with that in there, I don't even have to turn anything, just hit a button and the whole thing just goes. So I may do that. We'll see. This works pretty well as is, but push button means I just got to push something and the blade raises and lowers. The only thing about a push button is, like that, that's all the way up. So I can slide an 18650 underneath there, which could be bad. Because, like, if I lowered the blade right now, the blade would go right through the cell. That's not a problem. But like a 21700 will just catch the edge, so that won't slide under. So I may want, if I do use a push button, I don't want this going up to that extreme. I want it to stop, something, I guess, about like that. Yeah, probably about like that. And that way I can't put a cell underneath there. And that would probably take care of most scenarios. And as you can see on this, the little indicator on the pot, come on, camera, focus on there. Focus. Yeah, you can see kind of on there. Yeah, the little line on there. So there's a lot more travel up this way, and that spot for an 18650 is this much motion. So whatever that is, about 60% of motion. So yeah, I would put another trimmer pot in there to make that thing from maxing out, or to be able to adjust that max plus the resistor, and that way I could just use a resistor, and I could have a maximum in just with a push button, and it would just constantly do the same chop over and over and over again off of a push button rather than turning a pot. I don't know. I might do it. I might not. This is working so well, I probably don't care. But yeah, that's the whole thing. This disc right here, I bought that on Amazon for whatever it was, $10 or $12. This is just a piece of steel that I cut into a circle and then matched up the slot and added it on there. That way I could get a little bit more travel out of the servo. But with this position like that, it's almost not needed. You know, all the way down like that, there's still enough of the original one in there that it doesn't matter. But anyway, the extra disc on there just makes it have more travel on the servo. It's kind of hard to see it in here, but there's like this shoulder down on the bottom part. So initially, this little rod was kind of moved around in there. It had like about 1 millimeter worth of gap, and so I added a little brass shim underneath here and soldered it in place. And now there's no movement there. And the only movement that's in the system is this right here, and that's all in the servo gears. That's not in this gap. This part right here is nice and stiff. So anyway, a little bit of slop that was in the system. I took out that as much as I could. Originally, I had a 100 millimeter single bearing block linear rail in here, and that's this guy right here. Anyway, so this guy would allow a certain amount of wobble this way, because you know there's a lot of leverage in this little bit of bearing block, and it would also allow a little bit of movement this way. But with this one here, which I think was a 1,000 millimeter or 10 centimeter linear rail, so it's beefier, it's wider, and also it's got 2 bearing blocks. And so with those 2 in there, yeah, all that movement was totally taken out. So now there's no chance of any flexing or moving or anything like that. It's just rock solid. I think in my other video you can see that this rail would sometimes shift a little bit. And, well, that doesn't happen anymore. That's just completely soaked up with the 2 bearing blocks and the beefier rail. So if you're looking to build one of these things, I would say this worked, but this is much more secure. Yeah, just go with a larger one that's got dual bearing blocks. Probably the bearing blocks was the real critical issue, and not the actual linear rail. Yeah, go with 2 linear rails or 2 bearing blocks on your linear rail, and then you'll take away all the motion. Probably this little steel rail was plenty beefy enough. It was just that there wasn't enough bearing block to hold it securely, because you are putting a lot of force on the thing, and they weren't exactly designed for this use. So there you go. Well, hope that helps some folks out. If you recover cells like I do, geez, you need to build one of these things, because this is so much better than flush cutters and getting, you know, that kind of result. If the camera would focus on it. Yeah, you know, get totally flat, smooth cells. Yeah, you can see those welds on the bottom there. And, you know, that one right there, you can see it's just completely smooth, just like a brand new cell. This is way better. It's way faster. It's much more consistent in results. And yeah, the faster part is a huge deal. Yeah, it takes like a second to plunk a cell in there and turn a knob to chop off all those welds. Okay, maybe 3 or 4 seconds. Whereas to get, you know, results like this where you've got welds still stuck, you know, flush cutters. Yeah, this takes like probably a minute or 30 seconds per side of a cell to finish that up. So yeah, the Mr. Snippy is way faster and does a way better job. Well, hope to help some folks out. Take care. Talk to you later. Bye.